Alright, we're continuing the troubleshooting process on the 20X, the Zenith 20X1C38 chassis. Right here I've got my resistance meter looking at the output from the B plus power supply to ground. It shouldn't be 1.5. That's usually runs, 1.5K. That's usually runs anywhere from 8 to 12K on most TV sets. You can kind of do the math and see where that puts the milliamp draw on the B plus. But that's generally where you're looking at, just as a ballpark figure. Now I'm going to, and the reason I'm doing this is what I've done is I've grounded one of the leads, which on this transformer is that black and red lead, which is driving the convergence circuit. If I unplug that, essentially taking the convergence circuit out of the, you'll see I'm at, well, let's see where's it. I'm at right around 7.5, 8K resistance overall in the B plus. Of course, you know that resistance is just filter cap leakage, various resistors, all kinds of stuff that's in the B plus. Clearly, that isn't the true resistance when the set is warmed up, because plates start to conduct and all kinds of things start to happen. But generally speaking, it's not wise to power up a set if you don't have that kind of resistance, because you're gonna blow something up if something's not right. And what blew up on me last time was that resistor. Now I've replaced it again. This resistor smoked. When I first replaced it, I just assumed that the old resistor had, just gone bad. Bad assumption on my part. I know better. I should have tried to make sure there was no load. I checked some of the obvious things like shorted decoupling caps. I think I covered that. But, everything seemed okay. Of course, when I was checking things, you have to remember I didn't have the convergence board plugged in. Right? And I still don't have the convergence board plugged in. And I'm going to go do that just to triple check everything. I looked at the schematic, and I actually measured the leads on the convergence plug, which is outside, out in another room. And when I read that reading, I had about 100 ohms from the black, white, and the orange white. The black white is here, and the orange white is this is basically these two, the orange wire and this red and black. And I had about 100 ohms from either one of those to ground. That's why I'm using the ground lead here. Well, it's not 100 ohms, it's 1 ohm, to simulate what happens when you plug in the convergence board. You attach the lead, and I didn't attach the lead to the right spot. Right here is where I need to attach the lead. There, that's the red and black. When I do that, again, my resistance drops down to 1.4, and that's basically what I believe what's been going on here. What's been smoking this resistor is there's a leakage between the windings of this orange and black and this primary. I'll know that for sure. I will unsolder these. This is a single winding. This is not an autoformer. This is a separate winding, completely independent of the primary, so it really shouldn't have it. I'll show you that on the schematic here in just a second. So if we look at the schematic, that's this winding right here. Let's see if I can focus on that. Well, anyway, it's that bottom winding, and you see it goes through a diode and a resistor, and it goes to the socket plug. And the bottom of this, you'll just have to take my word for it, isn't connected to anything. It jumps over that lead. So that shouldn't have any kind of connection, especially with the convergence board unplugged. There should be no resistance between. There should be infinite resistance between this winding and anything else, especially this primary lead of this transformer. But if I check that, by going something like this, what I'll do is I'll just connect up to the blue lead of that transformer, which is one on the primary side, and the other lead from my digital multimeter. Excuse me for a second. I'll go ahead and make a quick connection here to here. There. Now I've connected up my multimeter to one of these leads, one of these secondary leads that drives a convergence circuit. Well, I thought I had the clip just dropped off. Wait a second. I'll try that again. This is so hard to do with. There we go. Alright, and I have that connected up, and when I do that, I get 11 ohms. That's not right. So, that tells me there's definitely, remember the convergence circuit, the convergence board is not plugged in, so that orange, that red and black and that orange, which are the secondary lead that drives, they don't connect up to anything. It goes through a diode and a resistor and it goes boom right to that convergence plug. So it's not connected up to anything at all. Yet I have an 11 ohm connection between that, and I'm curious if it'll be the same value on the other side. 11 ohm on the blue side, and let's check on the other side. I think I can get that by going right here. I'll try to connect up to that resistor. I don't know if I can get in there this way. I'm just going to go from the top side over here, which I think is right. There we go. That's good. Way to go. Dave. Arg. Hold on. Oh, I thought I had it. If I had another clip lead, I'd just clip onto it. Well, heck. Duh. We'll clip on to this one. Okay, that clip lead now goes through a terminal that goes to that red. And just to make sure I'm doing this right, I'll first read that transformer, as I recall, is about 460 ohms. So we know that from the blue to the convergence was 11 ohms. Okay, the total primary resistance is 460. Now, to that same connecting point, let's see what I get. Oh, look at that. So that tells me it's shorted right at the blue side of the primary. The red side of the primary is it's 400 ohms away from the from the short at the convergence. So that tells me the blue lead is basically shorted to the convergence lead. So anyway, let me just double check that. That's the red lead. Now I'll switch this over to the blue lead. 11 ohms, yeah. That's definitely not right. So this transformer's bad. Took out that resistor. Probably was causing the whole problems in the first place. I should have done a better diagnostics of this. I could have maybe saved myself the trouble of smoking yet another resistor. But it looks like there's no getting around it. I'm going to unsolder these leads to make sure I'm absolutely positively right about the isolation aspect of it, and then I'm going to compare that to another transformer, and we'll see, you know, if it's the same way. But from the way I read that schematic, that red and that orange should definitely not be shorting out the B plus. I mean, it's kind of configured. It makes sense too, because when I plug in that convergence and it goes from 8K on a cold chassis down to 1.4K, then that can't be right. There's no way that makes any sense. So that's just another way I can confirm it. I'll actually plug in the convergence plug just to make sure I'm not being stupid about this, but I'm pretty sure I've already checked out everything. by looking at the schematic, I could see a ground path that would make about 100 ohms. Makes about sense. Anyway, I'm going to have to replace this transformer. That's all there is to it, and I didn't want to do that, but I don't see any other solution. I don't know if perhaps that short circuit is something that could be easily found or not, but it's just the way it is. These vertical outs go. All right, more to come later.